Hello, and this time I'm looking at adding and subtracting algebraic fractions, and the method for this is exactly the same as the method for adding normal fractions. There's just a load of algebra to deal with. So I'm just going to go through the examples, and so in this case, in all cases, we need to find a common denominator when we're adding and subtracting, and it would be tempting just to times everything together, but I wouldn't recommend that because then what you're going to end up with is a lot of stuff to then cancel down. If we notice x is already common to everything, so that's all right, and so we just need a number that will be common to all of these, so a number that all of these can be scaled up into. So I think 12 is probably the sensible one, so 12x. And then we need to do equivalent fractions for each of these. So what do we times 2x to get 12x? We times it by 6, so that becomes 6. Take away, we times this by 3 to get 12x, so this becomes a 3, 1 times 3. And this we doubled, so this becomes a 2. And now we can just simplify this. 6 take away 3 is 3, plus 2 is 5 over 12x. And we can't simplify it any more than that, so it stays like that. Now, in the second example, we haven't got the same thing. You might say, oh, look, we've got x in both of them. No, because this isn't a factor, okay? So here we can say we've got an x and everything because x is a factor of 6x. Here, x is not a factor of x plus 1 because of the add. So you have to treat that as one thing and that as one thing. And so the only thing we can do here is just times them together. So on the bottom, we're going to have x plus 1 and x plus 4. Don't expand that. Leave it like that, because if we are able to cancel anything, it will cancel in brackets, so leave that. What did we times x plus 1 by? Well, we times it by this bracket, so we'll do the same for the 5. 5x plus 4. What did we times the x plus 4 by? We times it by this bracket, so we do the same, 2 bracket x plus 1. Now the top we do need to expand and simplify, and then we can refactorize and see if it will cancel with something here. So 5x take 2x gives us 3x, 20 take 2 gives us 18, which is over our double bracket, but this will factorize, and we get, I'm just going to write it to the left here instead so I don't run out of space later on. So we can factorize out the 3. 3 bracket x minus 6 over x plus 1, x plus 4. Okay, well it turns out that even though it did factorize, that bracket isn't going to cancel with anything here. Unless I've made a mistake. I have made a mistake. That should have been a plus. We had 5x, we took away 2x. We had 20, we took away 2, so it should have been a plus. But even so, we end up with x plus 6, and this is x plus 1, x plus 4, so it doesn't cancel. So, never mind. But can you see how I factorized it? Because if that had been an x minus 4, then it would have cancelled beautifully, and I just crossed out the brackets. In this one, you've got to look at the denominators and think, oh, right, okay, quadratics, do it in the brackets. There's no point just timesing this whole thing together. Maybe you do need to, much easier to do it in brackets, and there's a good chance that they'll share a common factor already. So let's do that. So x plus 1 over and x minus 3 over. This is a difference of two squares. So this is x plus 1, x minus 1. This one we'll have to do the old-fashioned way, so we've got an x and an x. There's only one way to make a 3, that's 3 and 1, and they've both got to be minus to give minus 4. And if you look, they both contain a minus 1. So the common denominator, we've got, whoops, that's supposed to be a minus 1. We've already got that common, and then we need each of the things that are not common. So we need x minus 3, and we need the x plus 1. So what do we times this by to get this? Well, we just times it by x plus 1. So that gives us x plus 1, which we already had, times another x plus 1, so that's squared, minus, and what did we times this by? Well, we actually times it by x minus 3, so actually this gets squared as well. Now, what you could do in this case is square that, x squared plus 2x plus 1, and square this, but with the minus sign, it will be minus x squared plus 6x and minus 9. Mush all that together and refactorize and see if anything exciting happens. But I'm not going to. Why? Because actually it's a bracket squared minus a bracket squared. Now this is unusual. Normally, if that had been a 5 there, we'd have just had x minus 3 times x minus 5, and you'd expand that, and you'd expand this, and you'd simplify it all together and factorize, a bit like we did here, but it would have been a quadratic. And hopefully things cancel. But because this is a bracket squared minus a bracket squared, this is the difference of two squares. So we can write this as this square root of this, so x plus 1 minus the square root of this. So this is minus x minus 3 times x plus 1. So we had minus that time, so plus x minus 3. So we need another bracket in there as well. Okay, so just like difference of two squares, you have the square root of this one plus the square root of this one, and the square root of this one minus the square root of this one. But of course, we can just simplify this because we're saying x minus x, and we've got 1 minus minus 3. So actually, we can just do a lot of cancelling here and say that those x's are going to take each other away, and 1 minus minus 3 just gives us 4. So actually, that whole thing can go, and we've just got 4 times, and this time we've got x plus the x, so that's 2x, and we've got x minus the 3, well that's minus 2. Okay, and it's still over the same denominator, so we've got our x minus 1, x minus 3, and x plus 1. But look, this factorizes even more. We can bring the 2 out, so let's bring that 2 out, and so that 4 becomes 8. And we need a 1 there, and oh look, we do get a cancel. The x minus 1 here cancels with this x minus 1. So finally, we do get a slightly easier answer of 8 over x minus 3, x plus 1. So we got there in the end. So, quick summary, if you already have common factors, then just have that in there, don't make work for yourself. The bits that aren't common, you need to find the common denominator and put that in. If you've got just two separate denominators like this with adds, then it's just times them together in brackets and cross multiply in order to get the numerators. When you've got something more complicated, you'll have to factorize the denominators, and then you can look and see if there's any common factors. Any that aren't common, you'll need to include and cross multiply so that you do the equivalent fractions. You might have to expand these and simplify it and then refactorize it to then look for cancels. But if you've got something snazzy like this, then you might be able to cancel it down in a different way like we did here. And ultimately, if you end up with something on the top and something on the bottom, then you can cross them out and get your simplified answer. If you have any questions on that, you can put them into the comments. Otherwise, ta-ra for now.